Hello everyone, today in this video we are going to talk about relative velocity, and after this video you should be able to define relative velocity and derive the formula of relativity and apply the formula. Now we will understand the relative velocity by taking the example of motion of this car. Now we have two cars out here. So suppose this car is moving towards the right. So for someone inside this car will appear to move towards the right with some speed. Now in second example, this I'm taking the same car and one more car, and they are moving in the same direction with same speed. So this time this red car will appear to be at rest for someone inside the orange car. And now in this example, this car is moving with the same speed as previous, but this car is overtaking this car with more speed. So this time this car will appear, so this time someone inside this car will see this car slowly moving backward because it is overtaking this car. So now in this example, this yellow car is at rest and this blue car is going towards the left, and this time someone in this blue car will see the yellow car to be moving towards the right. As we have seen, a rest car seems to be moving, and instead of a car at rest, if we take the same red car that we have been taking, this time this car will appear to move towards the right with more speed. So in all the example we have taken, we had the same car moving with the same speed, but for different observer, speed and direction of this car was different. So we have a problem, and answer to this question is relative velocity. So velocity of an object depends on the velocity of other object. So relative velocity means whatever speed of A will appear to B will be the relative speed, and that speed depends on the speed of B also. If VA and VB are the velocities of the object A and B with respect to ground, that means if we look from the ground without moving, that time their velocity is VA and VB. Then if I write VAB, that means the relative velocity of A with respect to B, that means the velocity of A which will appear to B. And if I write VBA, that is relative velocity of B with respect to A, so the velocity of B which appears to object A. Now we'll derive the expression of relative velocity, and this expression is for one dimensional motion, meaning two objects are moving in same direction. So we are considering two objects A and B moving towards positive x-axis with a constant velocity VA and VB. So at time t is equal to 0, suppose the position of A is xa0 and the position of B is xb0. So now I want to find their position after time t. As they are moving towards the right, they will cover some distance during time t, so they will be in new position. So we know the formula, velocity is equal to displacement by time. V is velocity, s is displacement, t is time. So displacement is v into time, so the distance covered is velocity into time, and we know velocity VA and VB, and we know the time also, so we can find the distance covered by these two objects in time t. So for object A, the distance covered is velocity into time VAT, and for object B it is VVT. So suppose after time t, the position of object A is xat and position of B is xbt. Xat will be given by initial position plus distance covered. Similarly for object B, the initial position plus distance covered is the final position. So now I'll subtract equation 1 from equation number 2. So xbt minus xat is equal to this minus this. So next I'll open this bracket. So now I'll take xb and xa towards to left hand side. So now I'm taking this xb 0 out here and xa 0 out here. So when xa 0 goes this side, it becomes positive. Now this is xbt minus xb 0 minus xat plus xa 0. So next I'll take the minus common from this side. So when you take minus common, that time it will become xat minus xa 0 is equal to vb minus va into t. Now if you see this, this is final position minus initial position. That means it is a displacement of object b. So similarly out here it is final position minus initial position, that is the displacement of a. So displacement of b minus displacement of a is equal to vb minus va into t. So displacement from a to b is the displacement of b minus displacement of a. So this will be given by vb minus va into t. Now you can see this distance is the displacement of b from a, so that can be written as displacement of b with respect to a. So now instead of displacement from a to b, I am writing relative displacement of b with respect to a. So it means the displacement of b which appears to a. So if someone look from a, that time the displacement of b will be this distance. So this is the relative displacement of b from a. Now instead of displacement from object a to b, I'll write relative displacement of b with respect to a. So this will be vb minus va into t. So now I'll take this time this side. Now we know displacement by time is velocity. So relative displacement by time is equal to relative velocity. So relative velocity of b with respect to a, meaning the velocity of b which appears to a is given by vb minus va. So for relative velocity of b with respect to a, I'll give the notation that is vba, meaning relative velocity of b with respect to a is equal to vb minus va. So this is the formula. So relative velocity of b with respect to a is velocity of b minus velocity of a. Now if you want to find the relative velocity of a with respect to b, that time you just interchange a and b. So relative velocity of a with respect to b is vab is equal to va minus vv. Now this is the general formula. So relative velocity of 1 with respect to 2 can be written as v12, and this is v1 minus v2. So whatever you write out here, you write the number in the same order. If you write 1 2, you will write v1 minus v2. If you write 2 1, you will write v2 minus v1. Now we'll see some real life example of relative velocity. Suppose this car is at rest and this car is moving with 10 meter per second. So we have observed when we see a car at rest from a moving car, that times we see that car moving backward with the same speed with which we are going forward. So now out here the velocity towards the right is positive and velocity towards the left is negative. So let's find v21. So that means what is the velocity of this car which appears to car number 1. So velocity of 2 with respect to 1 is the velocity of car 2 which appears to car 1. So v2 minus v1. So v2 is 10 and v1 is 0 because it is at rest. So someone from this yellow car will see this car, this red car, going towards right because positive is right with the speed 10 meter per second. So it's fine. So now next, now someone is looking at car 1 from car 2. So this is relative velocity of 1 with respect to 2. So this will be v1 minus v2, and v1 is 0, v2 is 10. So if you find the value, then you will get minus 10 meter per second. So that means someone from this car will see this car going towards the left with the same speed of this car. So that means this car will appear to move backward. So this kind of thing we have observed while moving in the car. So next, suppose both the car is moving with the same speed and the direction is also same. So this time, so velocity of 1 with respect to 2, that means velocity of 1 which appears from 2 is v1 minus v2. So this 10 minus 10, so 0. So that time we see this car to be at rest. Even we can talk with the person in another car if they are moving with the same speed. So the person inside this car will appear at rest because relative velocity is 0, though they are moving with some speed. So now if you look into car number 2 from car number 1, that is relative velocity of 2 with respect to 1, that time also 10 minus 10, so 0. So if two car is moving with same speed in the same direction, so both the car will appear at rest for each other. So in this case, the car 1 is moving towards the left with the speed 10 meter per second. So negative speed means going towards the left, and this car is suppose going towards the right with same speed 10 meter per second. Now let's see the relative velocity of car number 1 with respect to 2. So this is v1 minus v2. So v1 is minus 10 and v2 is minus 10, so that means minus 20. So the yellow car will appear to move with speed 20 meter per second, double the speed of the car, and moving in the negative direction. That means this car will go towards the left with very high speed, that means double of the speed. And if you look into the red car from yellow car, that time v21 is v2 minus v1. So this is v2 is 10 minus v1 is minus 10, so it will be 20 meter per second. That means positive means it will appear to move towards the right with the speed 20 meter per second. So the car will appear to move faster if they are moving in opposite direction, and if they are moving in same direction with the same speed, they will appear to be at rest. So now let's solve one question. In this question, a jet is moving with the speed of 1000 km per hour and it is ejecting hot air from its back. So someone inside the jet is seeing the air coming out with the speed of 800 km per hour. So this is the speed with respect to jet, means someone from inside the jet is seeing the gas coming out with the speed of 800 km per hour. Then we have to find the speed of the air from the ground. So if we look from the ground, what should be the speed of this air? So if you see, the velocity of jet is in one direction, but the gas will come out into another direction, so it will be negative. And if you see from the jet, it will look like this. So you are going in forward direction, but the gases are going in backward direction. So you are seeing these gases are coming out with the speed of 800 km per hour. So but we want to know the speed if you look from outside, so this speed. So direction of jet is positive, that means velocity of jet Vj is 1000 km per hour, and velocity of air with respect to jet means someone is looking at air from the jet, that is minus 800 km per hour, because this direction is opposite direction. So we have to find the velocity of air with respect to ground, that means real velocity of air. So that will be Va. So we know relative velocity of air with respect to jet is equal to velocity of air minus velocity of jet. So we need to find velocity of air, and we know Vaj and we know Vj. So if you put the value, you can easily find the velocity of air. And this is the similar question. The jet is moving with 500 km per hour and the speed of combustion gas is 1500 km per hour with relative to jet. So someone is looking from jet and seeing the gas coming out at the speed of 1500 km per hour. So you have to find the speed of the gas for the person who is standing at the ground. So in this question, there are two trains, one is moving north and one is south. So the train A is moving north with the speed of 54 km per hour and train B is moving with the speed of 90 km per hour towards the south. So this is the picture. A is going towards the north with 54 km per hour and B is going towards the south with 90 km. So this we are taking as the direction towards the north we are taking as positive and direction towards the south will be negative. So VA, velocity of train A, is plus 54. So I am converting into meter per second, that is 54 into 5/18. Similarly VB also you can find it. So first thing I have to find is velocity of B with respect to A. So that is VB minus VA. So VB is minus 25 minus VA is 15. So minus 40 meter per second. So if someone from A is looking at B, that time the B will appear to move with 40 meter per second towards the south. Minus sign means towards the south. So relative velocity of train B will be greater than its real velocity, because if they are moving in opposite direction, the relative velocity will increase. Now next question, we have to find the velocity of ground with respect to B. So velocity of ground is 0 and velocity of B is minus 25 meter per second. So we have to find VGB, velocity of ground with respect to B. So VGB is question mark. So VGB is VG minus BV. VG is 0 minus 25 minus of minus 25, so it will be 25. So positive means towards the north. So if someone look out from train B to the ground, that time the ground will appear to move towards the north with the speed 25 meter per second. So in next question, there is a monkey moving on the train and someone from train A is seeing this monkey moving with 18 km per hour going towards the south. So we have to find the velocity of monkey for a person who is at ground. So relative velocity of monkey with respect to A is given. So I can write velocity of monkey with respect to train A is equal to minus 10, because it is going towards the south. So if you convert this into meter per second, it will come as 5 meter per second, and negative means it is going towards the south. Now we have to find velocity of monkey with respect to ground. So we know velocity of monkey with respect to A is equal to velocity of monkey minus velocity of A. So this is the formula for relative velocity. So now I'll take VA that side and I'll flip the equation. So V monkey is equal to VMA plus VA. So VMA is minus 5 and VA is 15. So VM is 10 meter per second. So velocity of monkey is 10 meter per second. Velocity of monkey for an observer outside the train is 10 meter per second. That means the monkey will appear to move towards the north with the speed of 10 meter per second. I am saying north because the velocity is positive. So positive velocity is towards the north. So this is the end of the video. Don't forget to like the video and subscribe the channel. Thank you.